Okay, so I have restarted the stream.
What?
I've read a lot of the spec though, because I worked on a compiler for a while. And one of my favorites was like how if you have an array of one element, in certain cases, it will pull that element out if you're like adding, you know. And it's like one of the stupidest features of any language, but yeah, I love JavaScript.
So I did restart the stream, and now we're on the correct channel, and I'll just download the parts and merge them and then put them together to make that available. So sorry I was broadcasting to the wrong streams, but that's when you manage multiple meetups. It happens.
It's hard to be you.
It's hard to be me. Thanks for the empathy and the sympathy, or the whatever that was, or the sarcasm.
Yeah.
It's all appreciated. All right. So anyway, what I'm saying is that the language gives you good tools so that it's more ergonomic to do the thing that's safe and efficient than it is to do the thing that's unsafe or inefficient. So, Go, you're in a runtime in a container, you can't do the wrong thing. Rust, so in so much as the compiler detects things correctly, it's compiled in such a way that you can't do the wrong thing. You can't compile code that does the wrong thing. So Go has a runtime. The runtime enforces that you can't do the wrong thing. Rust compiles so that you can't do the wrong thing in the compile step. Zig takes the approach of just make it really, really easy to do the right thing, so much so that it's easier to do the right thing than the wrong thing.
Well, I think the biggest difference here between those things is that with Go and Rust, especially Rust, there's a Rust way of solving something, which is not necessarily the way that you want to or the best way. Whereas with Zig, you can do whatever you want, really. Whereas with Rust, for example, you have to solve it the Rust way. And a lot of times they'll have specific abstractions for solving specific problems.
Yes.
And they can play weirdly with each other. And so, yeah, with Zig, you're just able to do what you want to do. So that's like the difference between a walled garden. It's like you're constrained over here. Zig, you're not constrained.
Right. And I actually am a big fan of constraints, but I think that as long as, and there are a fair number of constraints in the language. I mean, it's not a dangerous language like C. You have to, and as it gains popularity, there will be more people who reach for the wrong tool. But I think the tooling's good, and it's getting even better, and the language is good, and it's getting even better. And I think that, I'm sure GPT will produce some crappy code, and I'm sure some people will do some really bad copy pasta. But I think that people that intentionally choose Zig on purpose will be self-selecting as a group that doesn't reach out of their way to shoot themselves in the foot.
Could I give an example? So in Zig, we really care about detecting memory errors. And so every single time we get a pointer back from the allocator, we want to check that it's not null. And in C, you can very easily just not do that.
Yeah.
Whereas in Zig, you can also decide not to check it, but you have to explicitly say, I'm not going to check it.
Right.
And so I feel like, you're able to do anything, but still the defaults of the language push you in a direction, through selectively applying friction. You're pushed in a direction of doing things the right way and doing things the safe way, but you can also make the decision yourself as well. So
yeah, so I really like that. I think that's a great feature of it. Another thing that I'm not going to be able to adequately explain. I think you might have some good ways to talk about this, but it has arenas over ownership, or GC. So typically speaking, in every programming language that I've ever used, I don't worry about the allocator. I know that some people, when they're doing real-time or they're doing truly embedded systems, not embedded Linux, but microcontroller code, they may deal with an allocator choice. I think particularly real-time OSs maybe. But here, you are always choosing the allocator, and that does feel a little boilerplatey, because with every data structure, you're either passing in the allocator when you create the data structure, or you're calling methods on the instance of the data structure that receive the allocator. So you're either choosing when you create it or you're choosing when you use it, but you're choosing an allocator. And you can have multiple allocators. And this concept of arenas, I suppose, has existed in other languages, but I had never heard of it before.
Go got it not that long ago.
Yeah, I did read about Go's arenas, and I'm not clear if that's a clear win, and I believe that that's also not under their compatibility guarantee. That it is an experimental feature that's available, and it'll be interesting to see. But at first blush, I just feel I have this sense that if you are in the situation where that's the problem that you have, Go may not be the right choice for you, or you might be using Go incorrectly. Because one of the problems that we have in the cloud world is that everybody's running everything on a single CPU, on half of a hyperthread, single CPU, really constrained environments to scale horizontally to the max. But they minimize their vertical scale, which is to the detriment. And this is true whether it's Go or it's Node or depending on how the architecture is built, because Go and Node both have this paradigm of concurrency built in. Rust and Zig, you opt into the concurrency as you want it. But if you're using a language that has concurrency, you must have 2 cores. Or at the very least, you need to have hyperthreading. But you can't...
Parallelism?
Yeah. Well, no, even concurrency. Like if you want to take advantage of concurrency, okay, so in both, so let's take Node for example. If you want to use the concurrency, you have to have 2 cores. I mean, you don't have to, it'll just be really inefficient. Because the way that concurrency happens is that there is another thread that has a task scheduler that is doing things in the background. So when you get your, you do your HTTP request or your database read, that actually happens on a separate thread. So if you're only using half of a hyperthread, then you're not getting any of the benefits of it being able to schedule things in an efficient manner. And the same is true of Go. Go routines don't work efficiently unless you, at the very least, well, I mean, for all intents and purposes, you have 2 virtual cores, or one real hyperthread core. So anyway, I don't know how I got on that tangent, but let me wind it back. Because garbage collection and stuff like that is one of the things I was going to talk about. Because of the garbage collection that Go has and that Node has, in particular, they offload garbage collection, so you get more stop the world runtimes and stuff. Anyway, so in these container environments, something. But there's multiple arenas. Oh, because that's what brought us to that. We were talking about Go arenas and with the cost benefit. So you get multiple arenas, which means that you can allocate essentially, pardon my French, multiple heaps, or not French, but abuse of the word. You essentially have multiple heaps, and so you can choose which heap you allocate stuff on, and you can throw one of those heaps, one of those arenas away wholesale. You can say, I'm done with this part of the program. Like I don't want to really manually manage this memory. I'm just going to let this arena do whatever it needs to do, use as much memory as it needs to use, and when I'm done with that process, I'm just going to dump the arena. And I'm not necessarily suggesting that should be a go-to strategy. It probably shouldn't be, but it's interesting that that's available. And it's also interesting that in choosing different allocators, you can choose allocators for different environments. So you can choose an allocator for your production environment that is less safe, but faster and perhaps more efficient. Or you can choose an allocator for your development environment that is slower, or maybe has different trade-offs in efficiency, but that gives you more safety and more error checking. So the general purpose allocator, which is often just abbreviated as GPA, and there's some other code that's not shown here that actually created that object and whatever. But here I'm saying, when this is being built, it's in debug mode, use the general purpose allocator, which will give memory leak warnings. So this is part of the tooling, is actually like in the language, in the compiler and stuff, similar to how Rust does it. So it's bringing that tooling just much closer to where it really needs to be. And so you can say, okay, when I'm building in debug mode, I want to be able to run my tests. I want to be able to see any memory leaks and fix them. If I'm not building in debug mode, then I want to use this. This is actually not the right allocator to use, because this would be allocating a page for every allocation, which would be an absolutely terrible thing to do. So pardon my bad example there. I should have, what's the allocator that should be there?
To be honest, a great Zig allocator is still in the works. A lot of people just use the C allocator for now.
Okay.
So yeah, when you want the speed one, a lot of times we just go with the C allocator, even though allocation in C using malloc is slower than in Zig, because it has to do more bookkeeping. It has to keep track of like the size of the allocation. Whereas in Zig, the size of the allocation is returned to you by the allocator, and you're expected to return it back correctly. And so that bookkeeping is not necessary. So that's one to do about that.
Okay.
And by the way, this is all just convention. So the language doesn't enforce that you actually have to pass allocators around, or that you have to hold on to references to allocators. And this is just the standard library thing. The general purpose allocators in the standard library. So this is all user land. So you could change this however you want.
But in practice, if you're going to write a Zig program, you are going to be. Yeah. You could write a Zig program from scratch that doesn't have this convention of allocator. But if you are going to, it'd be like me saying you can write a Go program that doesn't have garbage collection, which is technically true, but you wouldn't really do it.
Yeah. I just mean you can declare an allocator globally, so you can just say,
I'm
going
okay.
to use this globally, and you can just use it everywhere. So you don't have to like give yourself the option everywhere.
Okay.
You might switch it, but you can.
Okay. Well,
So,
yeah, I would have to see that example too.
just a global variable. I mean, literally a global variable.
Right.
Yeah.
Right. Well, but what I mean is like all of the data structure functions in the standard library,
Yeah.
they take, so you're not declaring it global and them using it.
Yes.
But yes, you
So
can
would
create
still have to
functions.
pass it in.
Right. So you don't have to have multiple allocators. You can write your function, your program simpler with a global variable, but you will still be passing the allocator to the data structure and stuff. And I don't have an example of that, but this is just basically the idea. Is you have multiple allocators. You can choose an allocator. You get arenas out of that. And I think that this beats both for Zig, because Zig is designed with this in mind. It beats out both Rust and Go in terms of the performance characteristics and the flexibility that you get.
I also think the syntax is cool when you say built-in .mode equals dot debug. So if people don't know, the dot kind of means infer in this case, so it infers the enum type to be built-in .mode's type. And so it's just going to say, okay, grab the type from built-in .mode and then do a .debug inside of that, and that's where it's going to debug from. So.
Yes. And that is also something that's much nicer than other languages where you have like the this or the self or like yes, this it knowing what type things are and you being able to reference the property rather than the package makes sense. And it makes sense because it's in this scope where built-in .mode is already there. Because the other thing that happens is that when things just get deconstructed all over the place and then you don't know where debug came from, here you can only use debug like this because it knows where it came from. So mode, built-in .mode is an enum that has different properties or different possible values.
The type is an enum,
yeah. Okay, so, and then it doesn't have macros, so we don't have the problem of Go generate where the macro system isn't really a macro system, but the code generation is a little too programmatic, or in Rust where it does a lot of magic, but then you have no documentation or no way to search for it. It's just the programming language. So if you want a macro, essentially, more or less, that is Comptime. And so here's an example of Comptime that isn't really macro-y per se, but it does give a flavor for what Comptime does. So here we have this multiply function, and we have in our code, we want to multiply 4 and 5. We can inline the Comptime here, and I think you'd also declare a function itself as Comptime. Is that?
You can't tag the multiply with the Comptime keyword, but you can make the parameters all Comptime, and that would, by definition, make it a Comptime function.
Okay. And so what this means is that basically at the interpretation stage, when it's going through and reading the text, it will, well, not exactly at that time, but
it's a CMA is what it is in the compiler. So it's the semantic analysis stage.
Semantic analysis. So during the semantic analysis, it will do the multiplication, and so this will never run in the code. And that, in this simple example, that's actually not surprising or earth-shattering, because I think that most language compilers would do the Comptime for this, because it is such a simple example that most compilers can recognize it and do that analysis. But it is a feature of the language, and it extends to much more complex examples. This is how generics work, is that you can do operations on types at Comptime. You can return a type from a function, and so the Comptime gives you generics. It gives you a kind of scripting in a way, and you don't have to learn a separate language. It's just Zig. All right, and then we have again, forgive my abuse of the word dynamic, but we have essentially dynamic types. So yes, they are static because it is a compiled language, but it is dynamic in the sense that it is inferred. So it's duck typed, and it is you just get to program with the flow. And so this kind of beats out Go's interfaces, and it also, because Go's interfaces are duck typed, but you're still declaring them all the time. The interface is literally just the documentation. You're not even declaring an interface. The interface just happens. And so that happens for the types and the generics. So here I have reader any type and writer any type, and that is essentially the empty interface if you're looking at Go, or it would be a generic. But there's not really a good comparison for this, because it's just duck typing. It's like, okay, what are you trying to do with a reader? Well, you're trying to read bytes with a reader, and so therefore something that has this function is what a reader is. So I can pass in anything that has this function, and that's a reader. Now when it compiles, if I have different cases where I'm passing in different types, if I'm using this function and I'm just passing in one type every time, great. But if I'm using this function in 3 different places, and I pass in, one's a network reader, and another's a file reader, and another is a buffer, a memory reader, then when it compiles, it's going to most likely generate 3 different copies of the function that are optimized for that type. And so that your sizes could get quite big and complex, and the compile times could increase if you are using lots and lots and lots of different types very generically. But it's easy to read, it's easy to write, it's easy to reason about, and you still get an error. You passed in this thing, but it doesn't have this method. Oh, okay, I passed in the wrong thing. Now, as a newbie to Zig, that can be a little confusing, because it is nice to have defined interfaces. But I think it's one of those things that you get used to it, and it just becomes part of your thought process, and you're used to it. So it's different, but I really like it. I feel like it's I feel good about it. It has a sense of power and simplicity without being magical. And then moving on, there's a few more things that I had here. I highly recommend the Road to Zig 1.0 talk by Andrew Kelly. I think that you'll get more concise information and better information than what I gave here in less time. But this is what I watched this talk, and I became a believer in Zig. It resonated with me, and he points out all the stuff I pointed out here, but just a lot better. So if you want to take a look at that, I'd highly recommend it because it's the creator of Zig, and he's better worded about it than I am. And then there's also the Zen of Zig. I think that great languages have a philosophy, and some bad languages too. But there's something to be said for having a written document that describes the why of this language. And you see that with the Scala Rationale, the Go Proverbs. Really, I think it originated with the Zen of Python. You also have, there's the Zen of Zig. There's a few others out there, but typically there's either in paragraph form or concise statements. But this gives us the why. So Zig is about communicating intent precisely, not having magic, or at least what magic there is doesn't feel like magic. It may do a lot for you under the hood, but you don't get the sense of hand waviness about it. It communicates clearly. Edge cases matter. So one thing that I thought that I had in here, but apparently I didn't have, was the way that the switch statements work, which is very similar to the way that they work in Rust, very much the way that I wish we had in Go. But the switch statements are exhaustive, so if any case that's possible must be addressed, or there's an error with it, and there's a way to opt out of that. But there's just lots and lots of, like we saw with the try or the catch. You don't hide the control flow. You don't have magic, and you take care to have concern about the edge cases and the exceptional cases. Favor reading code over writing code. This is great, especially to be explicitly stated, because sometimes people complain, boilerplate, we could have more magic, we could have more macros. But the truth of the matter is you're going to write code only as often as you read it. You're going to write the code the first time, and then you're going to come back 6 months later to fix a bug, and it's really important that you be able to traverse the code to understand what you did. Only one obvious way to do things, this is also in the Zen of Python, and that is, that's a goal. That's not going to be achievable. Every language that sets out to do this fails horribly. But the languages that set out to do this do, an order of magnitude or more better than the languages that don't. So when you look at Go and Python and Zig, yes, there are contradictions, but they're not at the level of PHP or C++. Runtime crashes are better than bugs. Yes. Compile errors are better than runtime crashes. Yes. Incremental improvements. Avoid local maximums. I'm not actually sure what he means by that. Reduce the amount one must remember. Yes, because we all have small brains because we're humans. Focus on code rather than style. Again, the art is in what you produce, not in the way that it looks in a text file. Resource allocation may fail. Resource deallocation must succeed. Memory is a resource. Together we serve the users. So that is the more philosophical philosophy. That is the Zen of Zig. And I think that was and then I did have to list a couple of cons, of course, because that would only be fair. So why not use Zig? I think the number one, completely obvious, is the maturity. I think that we don't know what the future holds. And this maturity applies not only to the tool chains and the language, but also the community. I think that the whole vibe of we're going to be an autonomous collective is just stupid. Immature, unwise.
What do you mean by that? Autonomous collective?
Like if you see on the website, like there is no official Zig community. The Zig community lives on in your heart, and if you want to create your own Discord, you can get it listed here. And like, I get it, but it's childish and fairy tale-ish. So stupid is not the right term because none of the people who are doing this are stupid. But I just wanted to be kind of brash and lay it down like I see it. And I think that could lead us into the same drama that we've had with Rust. It could also lend itself to funding issues. I think that it puts Zig in great political danger because the reality is there is a leader of a project or a group of leaders of a project. It is there is no such thing as something that, you know, like look at the way the GPL turned out, right? Like it's become a commercial instrument. So if you're not careful, your morals ensnare you. And that is something that I do have concern about with the Zig community. And I'm sure that those could be fighting words. And I don't really want to enrage anyone, but if smacking them on the head with hundreds of years of thousands of years of human tribalism, you know, don't wake them up and then make them enraged, then they need to be enraged because that's, I mean, you're not going to get rid of human biology by creating a programming language. So but I have not seen any bad out of that. I want to be clear. I'm just saying that hypothetically, there are issues that won't be solved well if that remains the mentality. Like we were talking earlier with Mastodon, right? Like Mastodon is this autonomous collective, everybody's going to work together, but it doesn't take off, it doesn't go anywhere. So those are the two big cons, but I think that Andrew Kelly has an excellent head on his shoulders, despite him being much a proponent of the autonomous collective. I think he's very wise and technically solid in what he's doing, and other members of the community. But yeah, those are the cons that I have, and so that's. But again, that it's a new thing, so that's kind of a given. I just think that some of it's a little bit more pointed because people could make the same argument about Go when it had a lack of maturity in the pre 1.0 days, and they were very slow to get to 1.0. But I think it worked out well. But
their garbage collector was garbage too in the early days.
Oh yeah, it was. Like the conference talks about like what it was going to do, it didn't actually do until Go 1.5 and 1.6. Yeah. So for it was like a decade, they were lying to people. They sold them on vaporware. Yep. But anyway, but there was leadership there and there was funding, and Zig does not have. How to say this? It has strength of leadership, but I worry about this autonomous collective mentality, and the funding is something that it will have to be figured out because there's people that could be doing great work on Zig, but there has to be enough commercial interest, and I don't know that donations are going to get it there. And as of the most recent kind of a State of the Union, which was I think last month or earlier this month. The funding situation is not looking great.
Yeah, they want more money. They need more money.
Well,
there are more people that could be doing work on this.
Yeah, and so anyway, I hope that things go forward. But regardless of that, why am I using Zig? I just jive with the way that it works, and I'm not using Zig a ton. I've got one small project in it that I've worked on for less than 20 hours so far. So I'm a little bit of not really poised in a position to either extol its virtues or criticize it from my brief interactions. But I want to see it go places. I love what I'm seeing. I think that we need something that is that middle ground between guardrails, the language, and the cool kids Kool-Aid. So.
And it has great vector support, unlike Go and Rust.
Yeah. Okay. I'm going to turn this over to you for a second.
Yeah.
And I want you go ahead because you've done the deep dives.
I think you got the camera.
What? Oh, whoops, wrong way. Yep, you're right.
Yeah, so I was looking up recently the support that Go and Rust have for vectors, and Go, good luck with doing vectors with Go, but Rust actually has the semantics where anytime you pass around a vector, it basically is semantically being passed through the stack, and so not doing that is considered an optimization over the semantics of the language, which is really weird to me, but it's for safety reasons, I guess. And you can do some unsafe things, but people always get scared at that keyword. But in Zig actually gives you direct access to the vector primitives that exist already within LLVM. And you can kind of get at this too if you're using C. But with C, you're writing intrinsics that are specific to a specific machine, and then a lot of times LLVM will take those intrinsics and it will actually convert it to like a general form. So if you're doing like a vector shuffle, for example, and you use this particular intrinsic, created by Intel, LLVM can convert that and say, oh well, it's a vector shuffle. Or a shuffle vector. I don't remember which one they call it internally, but yeah, in Zig, you're not doing that kind of song and dance where you're like, oh, I'm writing it for a specific architecture, but then it might get turned into a general architecture. In Zig, you're actually just writing, you're saying, declare a vector, it has 8 elements, each element is a byte, or it's a U64 or whatever, and you can do operations with it using, a regular operator. You can do arithmetic, you can do your AND and OR and XOR, and there are also a couple of built-in functions that are provided to you, like shuffle, select, and reduce. And so, yeah, Zig just has a lot better built-in vector support. There are still some things that it's missing. It's missing built-in compression and expansion primitives, which I've submitted a proposal for, and people are working on this. And then I also think, in my personal opinion, a lot of people want to move everything over to a standard library function, and then we have 3 things that are built-ins for vectors. And so, to me, I actually would like to see more of a consistent, more consistency on that, because some people like to say, well, anything that could be defined as a standard library function, we should just stick it in the standard library. And I don't necessarily agree with that, because especially with Zig wanting to have its own backend support, so it has its own self-hosted backend for x86 right now that you can use. It might be enabled as the default for debug mode. I don't remember if it was officially flipped on yet. And then there are other ones for ARM as well. Okay, my point was, for things like compress or expand for vectors, I think that should be a built-in, because it rather than having an implementation in the standard library where you have 8 lines of code that have to get auto-vectorized basically by LLVM or by Zig internals, instead it could map directly to a primitive inside of the intermediate representation inside of the Zig compiler. And so I think there's still some ways to go, but compared to other languages, you don't really have the general vectors that you have in Zig, and we're still waiting on machine-specific intrinsics, which you need for some applications, where it's like, okay, if you want to do this particular thing where it takes the floating point numbers and it does this particular operation with a particular precision, and that's only on this machine, whereas a different machine might have a different precision, or it might be a different operation. You still need intrinsics for things like that, but for a lot of things you can actually use these just generalized vectors that are applicable across hardware. And that's another thing I really like about Zig that you do not have in Go or Rust. So, yeah, that's my spiel.
Well, that's cool. I mean, I think that it is, well, in the cloud world, so I think the cloud has presented a lot of challenges for us where we're dumber. And I think that you would agree with that. We're not taking advantage of anything anymore. Everything's virtualized, everything's abstracted, nothing needs to be optimized, everything's going to scale horizontally, and it doesn't... it makes it really easy for cloud providers to charge a lot of money, but it's... at some point, we reach the level of the atom. At some point, regardless of political beliefs, there is an energy impact on the planet. There's physics.
Yeah.
Like, this is not a controversial thing. Where the whole world, everything's running on computers, if we can reduce the energy impact, we have to reduce the energy at some point. And maybe what's going to happen is there's going to be a World War III and we're going to wipe out half the population. I think that's probably the most likely outcome, is how we're going to become more energy efficient, is just, that humanity will self-delete huge swaths. But
this happens at our meetups a lot. We start talking about the death of everyone.
Yeah, well, anyway, but I don't know. The problem with optimization is that you optimize where the cost is the highest, not where the cost is the lowest. And you typically optimize where you're at right now. You don't want to do premature optimization, but something just kind of feels wrong about leaving so much on the table. And where it's like if you needed to eat and you had an entire banquet prepared for you, like if you're the richest man on the world, if you're Elon Musk, but there's a full buffet laid out for you every time you want a sandwich, it feels a little wasteful and wrong. And I think that's how a lot of this cloud stuff is getting. Like, it's the amount of waste is at a level of opulence, and we could just have so much more for so much less. But as long as there's investor money to drive it, like, the cost doesn't mean anything. I don't know, but anyway, what I'm saying is, philosophically, whether or not it's practical, philosophically I align with the idea that yes, let's learn how to take better advantage and squeeze the most out of the hardware, because the hardware is reaching its limits, and so software has to get better. Yeah. Okay, that's the succinct, non-controversial thing to say. Hardware is reaching its limits. Software will have to get better.
I hope so. Yeah. I do have a spiel about optimizing the hot paths versus the slow paths. I think that the main way that I optimize the slow paths, quote unquote, is basically really small, right? Is I don't want it to take up so much space in my instruction stream and give me more like instruction cache misses or instruction translation link side buffer misses or faults. And because if you write a function and it just adds a bunch of integers together, so you just define a sum function, and LLVM is going to turn that into 100 instructions, right? Because it's going to say, okay, if there are 0 elements, then return 0. Okay, if there's 1 element, then return that 1 element. And then if there's more than 16, or it depends on your hardware, then we're going to go into this Cindy loop. And then when we're done with the Cindy loop, where we're doing 16 things at once or 8 things at once, depending on how big of integers you're adding, then we're going to go to a scalar loop where it's just 1 by 1, just to pick up the last few, because probably your buffer is not aligned to that specific size. And then after that, we can return the answer. And the problem with that is that my add function, I might be using it on an error case. Like, it's not supposed to happen. I don't want it to take up 100 instructions in my instruction stream. And so I tend to think this way when I'm writing software, that it's like every single piece of code that I'm writing has performance characteristics. And even if it's something on the slow path or something that's an error condition, then I still have an optimization plan for it, but the plan is really small. I don't want it to take up 100 instructions. I don't want it to be vectorized. I don't want it to be able to add 1,000 things efficiently if I'm probably only passing in 5 things. And so yeah, so for me, I'd just say like, we're gonna have a built-in in Zig coming soon. It's at optimize for, and you can say release small at a function level. And
Nice.
so for that particular function, you can say release small. There are other ways of tricking the compiler into disabling optimization. So if you do std.mem.do not optimize away, what that will do is it will have an inline assembly which has like a volatile reference to a piece of memory. And so it will basically tell the compiler hands off, even though it's empty assembly. It's just the empty string. So it's going to splice in nothing. But it will disable certain optimizations that the compiler would otherwise do. And one of those would be like loop unrolling, for example. So you're not going to have the same loop. Oh yeah, that was something I didn't even mention with the add function, is it will copy and paste the body of the loop 4 times.
Right. Yeah, I'm
yeah. So
I remember that from the Gen 2 days because it was a meme.
yeah.
Were you around for the Gen 2 days?
No.
Okay, well, it's like the Arch days, but for real, man.
Yeah. yeah.
Step 1, you compile your kernel.
Yep. I've never done that.
I should compile everything, I think.
I use Pop
If you-
OS actually.
if you-
like this guy.
If you're a legit Linux user, you started a stage 1 tarball, and 72 to 184 hours later, then you can type ls.
But he just keep breaking all this.
What?
But I like Paul.
Anyway, so since I'm the host and the presenter, I have to ask for an awkward. Let's.
Please clap.
Yeah, please clap for the. I should have put a the end with a clap on here. I just didn't have the time to get that last slide in because I wanted to.
You want a slow clap?
You should pull up the example of returning a type that's on the ziglang.org.
Oh yeah, I should. I think that is a good example. I should put that in here. Well, I don't know. I don't know where this presentation is going to go. I'm glad that y'all showed up, and I'm glad that I got to review it, but I don't know if this is really of any
I think
value.
if you go to learn,
Let's see, learn.
and then go to in-depth overview, and then there's also the thing that's pretty similar to the title of your talk today.
Yeah. Yeah, I should have done this. I have gone through a little bit of this before. Okay, so what you're saying, let's see.
You could try the generic data structure and functions, 2 down.
Yeah, there we go.
Oh yeah, so types are values that must be known at compile time. And then, yeah, the next one shows a generic with a list. So you can return a struct type. So it's a function that returns a type. So you have compile time type reflection.
Yes.
So, and what's nice about that is that you can do arbitrary things with that, right? Just writing regular Zig, you can say, oh, well, if it's this particular type or if it's this particular size, then I want it to do a specific thing. And you can write arbitrary Zig code, the same language that you are otherwise writing in. You can arbitrarily define it, which is just so nice because in every other language, right, you have generics and there's a special syntax for it. There's specific things that you can do with it, and then sometimes they'll add more specific things that you can do with it. But in the languages where you can do anything, it's like a different language to do anything with it.
Yeah.
Whereas in Zig, it's the same language, and there isn't that much special. You just have a parameter that you get at compile time, and there you go. You can pass around the types at compile time.
Well, there's all those jokes, memes about macro systems that are Turing complete, and at the point that your macro system is Turing complete, yeah, why didn't you just use your language?
Right.
So and that is one of the, I think, greatest selling points to Zig is just when Andrew talks about the emergent design of Zig, it's really compelling to me. And how, yeah, I didn't want to think about how to do generics. I just was working through this problem and I realized, oh, yeah, I could just return this as a type, and boom, generics were born. I didn't have to make it complicated.
Yeah, small, simple language.
Mm-hmm.
Yeah, what are other ones that are in here? What are the other things here?
Back up at the top.
Yeah.
Oh, option type.
Yeah, that's always good. I mean, to be honest, I think at the beginning of Java, they probably could have done that too. But yeah.
Yeah, I don't know why. I don't know why Go didn't have some of these things. That's something that is strange to me because they say there's no null, there's just nil. Which, but one of the things that they got wrong is they're talking to a room full of system programmers. So in their mind, Go is a replacement for C and C++. But in everybody else's mind, Go is a replacement for Java and C#. And they miss their target market because from the perspective of somebody who's actually going to reach for Go, nil is literally the same as null because it is. But they're saying, no. It's not null like in C, it's null like in Java. It's still null, but they call it nil. But the option type is what, like when you hear the phrase, we don't have null in the language, what you expect is that there's an option type.
Yeah. Yeah, I'm with you. The terminology is a little weird. If you say, oh, there's no null pointers, it's like, well, there's a null pointer, but there's a type that says whether it could be a null pointer. Yeah. If you're on a platform that supports null pointers. Zig actually supports platforms where 0 is a valid pointer. If you use the allow 0 keyword, I don't know. If you're on a platform that needs that, that is available. But yeah, you always have pointers that are 0. It's just a matter of whether the type system actually helps you and tells you whether it's possible. So, yeah, if you go to
I was just thinking, I think I was thinking about the reason Java didn't serve optional is the same reason that Go didn't serve optional, which is that neither of them had generics to start with. And without generics, optionals, you have object or nothing.
Okay, but
yeah.
Go always has had generics in two forms. One, there's the built-in generics, the map.
Map and the lit, slice, I guess.
Yeah, map and slice,
Yep.
and
Channel.
then interfaces are like you don't need generics in Go because you have interfaces. Now in that particular case, like it would be an option interface with an error function that returns the error, and then you just have some sort of typecasting, because you can do typecasting in Go that will give something a function, right? So you can take an int and you can typecast the int into something else like age, and then be able to call a function on it once you've typecast it. So, they could have done it. It seems the mechanisms that they've always had there, they could have had it something in the language. I don't. There may be a deeply technical reason because they were really one of the things that they're hardcore on is fast compile times. Like that's where they're non-compromising, and so that was one of the reasons.
You talking about Go?
Yeah. Sorry, what did I say?
I'm just making sure.
Oh yeah. I'm talking about Go is hardcore on fast compile times, and they succeeded, and at very little cost, because it's the 80-20, it's the Pareto distribution. They had excellent compile times at just a cost that's in the noise in terms of the performance.
Yeah,
So.
Zig is going to be better though once we finally are able to digitally be on most of the time.
Well, I do worry about either the funding has to be better. Well, there's a lot of things that need to happen, right? But the funding would have to get there, and the path. I guess the question is Zig going to be ready in 10 years or 20 years, or is Zig a labor of love that may never get anywhere in the production environments, but
Python 3000.
will be Python 3000, but it's something that we just all love and feel good about, right? And I don't think that the latter is the case, but what I'm saying is you have to make trade-offs in order to achieve goals. And Andrew, one of the criticisms that people have made about Andrew is that he basically wants too much. Because if you're going all the way back to first principles and you're inventing, let's give the hyperbolic example is, well, we have to invent our own silicon in order to really make the language optimal, which is, that is the...
I bet we will one day, to be honest. Zig is a very radical project. And to be honest, I think people probably will at one point. There's a startup, actually, that was started by the architect of Zen architectures for AMD and some 20-year-old where they're like working on fabricating things in their garage at like 300 micrometer lithography. And yeah, so probably people in the Zig community will be doing this in 10 years.
Probably spell that name wrong. This is a talk that I just cannot recommend enough.
I think I've seen it.
And
It's a good talk.
it never shows up right in search. Let me see if I can get it to show up. It'll always pop up with the wrong ones, either the clickbaity ones or whatever. This is the correct one. This is the correct talk. But I would highly recommend watching this. Just one of the things, it's not super relevant, but one of the things that you just said about kids doing silicon in their garage.
Well, I will say right now Zig does have self-hosted backends. Like we do have an x86 backend that you can use right now. Some of the other ones are more like in the 80% range. But the biggest thing is going to be figuring out how to do optimizations. And the thing about LLVM, actually a lot of people are looking to replace it right now. There are a lot of movements, including like with Odin, for example.
I've heard of Odin.
Yeah, Ginger Bill is also planning on it. Jonathan Blow, I think he also wants to get away from LLVM.
He announced something a long time ago, 4 or 5 years ago, maybe.
Casey Muratori has been going on a bunch of different shows talking about how LLVM is horribly architected for performance, and there are a lot of people who are interested in getting rid of it. There are.
Who is the person you just said? Casey
Muratori, yeah, it's CASEY.
Oh.
And then space MURATO. Yeah, there you go.
And what should I be?
The first one right there. That's exactly what I was talking about. Yeah. So in that interview, he was talking about. Let me think for a second. I think in that interview he talks about it. He also has one with EasyPerf. If you want to look that up, EasyPerf Casey Muratori.
Hold on, I'm gonna make sure that I've got the links to these.
EasyPerf, the EasyPerf interview with him, actually, they go really, really hard on LLVM and that.
And then, so you said what?
EasyPerf.
Cool. I'll give these a listen.
Second one.
This one?
Yeah.
Oh, so it's the same title. It's just a different.
Yeah. So Casey Muratori made a video called
Oh.
"Clean Code Horrible Performance," and then he went on kind of a tour talking about it because it basically broke the internet in the tech sphere. But and so you'll find tons of videos with him talking about that video that he put out.
Okay, cool.
And basically talking about how clean code results in horrible performance, and basically the only principle of clean code that he agrees with is don't repeat yourself.
Which I do not agree with that one.
Well,
I thought you were looking at an old version of YouTube because it's not in dark mode. I was like, what is this? What is happening?
But yeah, point of my story is actually a lot of people are interested in replacing LLVM right now, and there are a couple of people with some ideas on how to architect something better. Andrew Kelly was looking at, I don't remember the person's name now, but there is a person who has an idea for like sea of nodes approach to compilation, and another project that I think has some legs. Luajit Remake is a project where it's a little bit different from, strictly speaking, ahead of time compilation. But one thing I find so interesting about it is you basically just define in regular code the semantics of a scripting language. You picked Lua first because it's the simplest scripting language that's widely used, and then it will automatically generate an interpreter and then a just-in-time compiler, and actually multiple levels of just-in-time compilation. And there's a couple of reasons why I think that is really, really awesome. But basically, just like as a force multiplier, you know, when you have, like, one of the things Andrew Kelly talks about is when we talk about how you can beat a project that has 1,000 times more hours than you have, or 1,000 times more funding or more. What you really need is you need extreme force multipliers.
Yes.
And so I think Luajit Remake is interesting for that reason, because it's like you're able to match things that are like hand-tuned with handwritten assembly for specific platforms by engineers, working on V8, for example. You're able to basically automatically generate these things. And even if, let's say that we didn't use that for ahead of time compilation, the thing that's interesting to me about that is one, it is a great centralizer of effort as well, because this is generally applicable. It can work for Lua, it can work for JavaScript, it can work for Ruby, it can work for anything. It could even work for Zig Comptime, and so these kinds of things where you have the ability to, you have a great force multiplier, and then on top of that, it can be kind of a centralizer. Those are the things that I think are going to be most powerful for advancing compilation. And then when it comes to the ahead of time stuff, I guess I don't know enough about the sea of nodes approach and then some of the other novel compiler techniques that people are working on. But I also would really like to see all these people like Jonathan Blow, Andrew Kelly, and Ginger Bill of Odin. All of these people want to,
What's one from Ginger Bill that I should look up?
I haven't watched him on YouTube very much, really. But yeah, Odin with an I.
Oh, right, I knew that.
Yeah. So yeah, he's got a bunch of videos. I haven't watched his videos that much, but I'm aware of the language. And yeah, the point I was going to make was I hope that the people who want to, do better than LLVM can kind of like coalesce and like actually engineer something very good. And yeah, one of the things Casey Muratori was talking about in that Easy Perf interview is a bunch of people were saying, well, you games programmers, you solved the problem of having horrible performance. Therefore, it was inherently solvable. Whereas, us compiler LLVM people, we're not able to solve this problem. Therefore, it might be unsolvable. And Casey Muratori made the point that he's like, well, actually, it is solvable, and the kind of workloads that LLVM does is not that terribly different from some of the logic that you see in games. And it's simply that games programmers have developed techniques for making that fast and engineering it well. And yeah, right now LLVM is engineered to just be like, I can make a pass and I just understand the pass, and then and I can just plug it in. Whereas basically any other design will probably be more efficient from a performance standpoint. And I understand the benefit of LLVM being like a noob-friendly compiler. People can jump in, but I really would like to see these people kind of like work on a design together, or kind of at least if there are different designs
Get in a
being
boxing
done,
ring.
coalesced in some way, like figure out a good way to do things. And this was one of the things that I wanted to address with my talk, and the part two, is that a lot of these things for how we make a compiler, we haven't really converged on the best way to do it. And there have been centuries, if not thousands of years of human effort dedicated to things like parsing, and how many people have actually applied SIMD techniques like I did to even just the tokenization aspect, which is what my previous talk was on. And I got a lot of inspiration from Daniel Meyer, Geoff Langdale, I don't remember the guy's first name, but Jay Kaiser on GitHub. They made SIMD JSON, and they're one of the few projects, like you can look, there are some other projects that are sort of similar. There are some people who could do like GPU parsing of JSON, but there are not that many people. Like I don't think you can open up the Dragon book and see a section that says like, oh yeah, there's a lot of data level parallelism here that could be exploited, and we're just not. And that's also something that Case Meritori has talked with Jonathan Blow about. So I sort of think what needs to happen is, sort of radical people like in the Zig community can come up with, a clean break.
It's so funny for you to call it a radical community when the principles are so simple and
Seriously.
non-confrontational.
I mean, they do have kind of like a nice culture, a culture of niceness, but I mean, they really are breaking a lot with.
I meant more just simple language
and even I think Jonathan Blow and Case Meritori are also very outspoken, and they break with a lot of other people's thought.
So circling back to something you were talking about earlier with the JIT stuff, are you familiar with the way that Rust does post runtime optimization? So there's
I don't know much about Rust, honestly.
Oh well,
except that I looked up the SIMD stuff.
There's a way to build kind of like a debug mode, but it's like a JIT mode, but it's a logging. It's not a JIT mode. It's a logging mode. So you run your application in production, and you take the performance data file that it generates, you feed it back to the compiler, and then it uses that to retune the application specifically for the way that it's used. So
profile guided optimization.
Profile guided optimization. I didn't know the term for it.
Yeah.
Because I think of it as JIT in reverse. Like rather than optimize your program as it's running, you recompile your program with the way it ran.
Yeah, we don't have that in Zig yet. There is an open issue for it.
Well, this is what I was going to say though. Is there's a million things to do, right, to achieve perfection in a language, and are the resources going to be there? Because at some level, you want to use the things that are already there, and work with the abstraction so that you can focus on the most important part, so that you can get the momentum and people can see the vision and there's a demonstrable working product. And it may be, in the sense I kind of get from what Andrew Kelly says, is that it's not actually as important to get all of the pieces of the language and the standard library out for people to use as it is to prove that the optimizations can be done so that the language is truly viable for the goal. So it's not about creating a great language, it's about creating a system of tools that can give a great outcome. And so if the language has to suffer and be prolonged in its development in order to get the underlying tools, then that is actually the priority, because the language perhaps serves no purpose or will not achieve his purpose unless those issues are addressed first. Does that seem to be accurate?
I would say that wasn't my interpretation of what I've got from watching Andrew Kelly over time.
Well, it just seems like and I don't mean this in the derogatory way that is often used. There's a lot of yak shaving. There's a lot of going to first principles. And that may be necessary for, like, the question is this a distraction that's going to make it so that we never get to 1.0, or is this the goal? And it has to be done. There's no point of a 1.0, because you don't have to have, well, I guess it's a little bit of a give and take, because if you don't actually do the experimentation, then you can't make sure that the language design is correct in order to facilitate the ultimate goal of maximizing these characteristics of performance and of user choice in control of the hardware. But if you go down that rabbit hole too far, then you may never get the language done, especially with limited resources. But there's also the curse of too many resources as well, because limited resources help people to focus on what's most important. And that, I mean,
So what are the things you're talking about specifically that need to be developed more? Okay, like, are we still talking about the self-listed backends, or like?
So the
those don't have to be there for 1.0.
well, in the State of the Union that he did, I'm calling it that because I don't remember what it was called, but one of the things that he was talking, and I haven't finished it yet, but one of the things that he was talking about was how the compiler is too slow, and so he needs to stop development on these other language features so that he can just focus on the compiler going faster. And I imagine you may be involved in some of those conversations because you are.
Yeah, I mean, the things that I've done certainly could be a part of that. I haven't spoken with him specifically about it yet, but
Why not?
well, honestly, I wanted to do part 2 because that was like the big thing.
Okay, all right. Well, let's
So
do. Okay, so as in terms of, I'll go ahead and bring this. I'll stop streaming. I think
Okay.
that the conversation that we've been having has been really good. I hope other people have found it interesting. We do have a few people that are viewing, so we're gonna say goodbye, everybody. Adios. Thanks for tuning in. Catch you later. Remember, I am an equal opportunity offender, so if you weren't offended, there'll be another chance. And if you were offended, sorry, not sorry. Adios.